Hello everybody, it's Sunday again, which means it's time to get back to basics. This week we're going to talk about the Coulomb, which is a measurement used in electronics that after today you'll probably never think about again. But it's important to cover it just at the start here, because it does help us understand a little bit more about how capacitors work. Anyway, pardon me. So the Coulomb is the SI unit of electric charge that is defined as being the amount of charge transported by a constant current of 1 amp in 1 second. So 1 Coulomb equals 1 amp second, or amps times seconds. We can also look at it in regards to capacitors as 1 Coulomb being equal to a capacitor with a value of 1 farad being charged to 1 volt. So you can see how many coulombs are being stored by a capacitor by just multiplying the farads times the volts of the capacitor. We can also define the Coulomb, and this is where things get a little interesting. 1 Coulomb has an equivalent charge of this is a really long number, 0.602, that's a terrible 2. 1.602, I'll just stop there, times 10 to the 18th electrons. Actually, technically that's negative 1 Coulomb equals 1.602 times 10 to the 18th electrons, which means that if you have a conductor with 1 amp going through it, if you measure at this point for 1 second, you've got 1.602 times 10 to the 18th electrons have passed through that point. Now, we can do some interesting math with this if we desire to determine how many electrons are passing through a resistor, and I'll probably do a short little drawing everything together video with all of that. Maybe next video I might talk about watts or farads. I have to decide. Anyway, where did I put my eraser? There it is. So let's revisit our water analogy one last time. So when we were talking about tanks of water, we had our big tank of water, and it was full to whatever level. And then off the side here, we had, actually I'll make it come out of the bottom just for simplicity's sake. So I'll do it here. And we have an opening in the bottom there with a little valve, and we can control the flow of that water by opening and closing the valve. Now, we'll remember that voltage is determined by the pressure of the water. So, as with water, given this point here and this depth here, the water exerts a certain pressure. And we can look at voltage in the same way. That column of water exerts a pressure here, or that column of electricity applies a pressure, so we have voltage. And it doesn't matter where you measure, the voltage is always going to be the same. So then we talked about amps. Now amps is how fast that water is going to be flowing through this valve. And we haven't talked about resistance, but if we close the valve, the resistance goes up and the current goes down. But the amperage is how fast that water flows through that valve. Then when we talk about coulombs with this analogy here, we're going to talk about how much water we actually physically have. So we can increase the number of coulombs we have, of course, by filling this to a deeper level or by widening it. If we fill it to a deeper level and keep the tank walls at the same distance, our voltage is going to go up, and so are our coulombs. If we make the tank wider, our coulombs are going to go up, but our voltage is going to stay the same. So it all depends. It's basically how much water do we have in this tank, and that's what coulombs are. So that's basically about it for a coulomb. It's worth noting at this point, and some of you may have noticed this, but when we've talked about volts, amps, and very briefly resistance, we'll actually go more into depth about resistance. That'll probably be the next video, actually. They are all defined using each other as references, which can cause some inaccuracies to work into the system. And the watt, which we'll cover later, which is volts times current, and you get watts, or in this, most people would say P equals IV. So the watt used to be defined using something, using the kilogram. But the kilogram is defined with a lump of metal that's sitting in a vault somewhere in Italy, I think. I should have written that down. And it's got copies of it that were made, and it's the only... It's one of the measurements that they're trying to change to define more exactly. In one case, some researchers have defined the kilogram as a very exact amount of atoms of silicon. They've got I think it's a 5 kilogram sphere of silicon, and it's a very exact amount of silicon atoms in it. But then we've got something called the Kibble balance, which is it's hard to describe, but it's a very expensive piece of technology that uses current and coils and a balance to equalize the current between two coils, and they're able to define both watts and kilograms using very exacting amounts of electricity, so that we have a perfectly exact definition of the kilogram. I'll probably go into a little bit more detail about the Kibble balance or the watt balance when we talk about watts. But the Coulomb, because we can very accurately measure the electron flow into something if we really want to, that's what the Kibble balance does. It's very hard to do, but we can do it. We can then define the watt or the Coulomb very, very exactly, and then from there we can define the volt, the amp, and the ohm from that point, rather than using the circular logic that everybody uses now. For the hobbyist, it's not going to matter. All that's going to matter to you for the most part is Ohm's law and Kirchhoff's current law. We'll talk about those. But I hope this has helped you understand the Coulomb, and we'll talk about Ohm's law in the next video. So I'm going to commit to that. So see you next week for the Ohm's law. Thanks so much for watching. If you enjoyed watching this, please consider subscribing if you haven't already. That button will be here. I'll have a video that YouTube thinks you'll like here. The Back to Basics playlist will go here. And right here will be a link for my Patreon. Patreon supporters get these Back to Basics videos 1 week in advance. So if you subscribe to Patreon, you'll be able to see this video 1 week ago. So thanks so much again for watching, and we'll see you next week. Bye-bye.